Let's talk about alkenes. Alkenes are hydrocarbons having only single carbon-carbon bonds. Physical properties. Inner molecular forces called London dispersion force are very weak. As a result, alkenes have low melting points and boiling points. The phases at room temperature depend on the sizes. Small alkenes are gases at room temperature, such as methane. The melting point and the boiling points increase as the number of carbon increases. Increase the surface area, increase the force of attraction between molecules, such as raising the boiling points and the melting points. You can see those examples here. This is the butane. The butane has 4 carbon pattern, 5 carbons, hexane, 6 carbons. You can see the boiling point increases with the increase of carbon numbers. For butane, the boiling point is minus 0.5 degree, pattern 36 degree, hexane 69 degree. Alkenes are nonpolar molecules and water insoluble. The 2 types of alkenes. One is acyclic alkenes and cycloalkenes. Alkenes that contain chains of carbon atoms but not rings are called acyclic alkenes. Cyclic alkenes has a molecule formula CnH2n plus 2, where the n is the number of carbon it contains. Cyclic alkenes are also called saturated hydrocarbons because they have a maximum number of hydrogen atoms per carbon. Cycloalkenes contain carbons joined in 1 or more rings. Since cycloalkenes have 2 fewer hydrogen atoms than acyclic alkenes with the same number of carbons, the general formula is CnH2n. Let's take a look at the simple alkenes. Cyclic alkenes having fewer than 5 carbons. Each carbon has a tetrahedral shape. This is a methane. It's only 1 carbon. Ethane 2 carbons. Propane 3 carbons. Butane 4 carbons. Butane has 4 carbons. It has 1 isomer. It's called isobutane. They look like this. This is the chain, 4 carbon chain. This one has a 3 carbon chain and 1 side chain and a branch. It's a methyl group here. Butane and isobutane are called isomers, 2 different compounds with the same formula. Cyclic alkenes have 5 or more carbons as the number of carbon atom in the alkene increases. So does the number of isomers. Take an example of a pattern. It's a pattern. It's a 5 carbon chain. This one has 1 branch at the 2 position. 1, 2, 3, 4. It's a four carbon parent chain. At the 2 position has the methyl group. The total carbon is still 5. This is a new pattern. New pattern, the parent chain, the 3 carbon chain. At the 2 position has they bond 2 methyl groups. This is called a near pattern. With the alkanes having 5 or more carbons, the name of straight chain isomers are derived from a Greek root. Pattern for 5 carbons, hexane for 6 carbons, and so on. The suffix ane identifies a molecule as alkane. Take a look at the examples. This pattern, the 5 carbon and 12 hydrogen. Hexane, 6 carbon, 14 hydrogen. Let's take a look at the carbon atom classification. The primary carbon is bonded to one other carbon. The secondary carbon is bonded to 2 other carbons. The tertiary carbon is bonded to 3 other carbons. Quaternary carbons bonded to 4 other carbons. That's the structure of those alkanes. The primary structure, this is the primary alkane, is the secondary carbon, and tertiary carbon, this one, and this is a quaternary carbon. All these are alkanes. All those compounds are called alkanes. Next, let's take a look at the bond rotation. Single carbon-carbon bond can rotate, so atom bonded to the single bonded carbon atom change orientation after the bond rotation. Take 2 examples here. This is icing, 2 carbon compounds. Then if we number the hydrogens after the rotation, the orientation of the hydrogens become different. This is another example. This butane. Butane has 4 carbons, and those carbon-carbon bonds can rotate. Take a look at this the bond between C2 and C3. This configuration is a zigzag configuration, and after rotation, this becomes a bolt configuration.